All right, so here we are with section 5.4. We have 2 goals today. We're only doing 1 section, 2 goals. We're going to be dealing with some vocab again for median and altitudes, and we're going to be talking about the concurrency of medians of a triangle and being able to use that to find missing segments. So, remember how I told you that you had 2 more points of concurrency? You already know about circumcenter and I'm going blank. An incenter. So you're going to learn 2 more today. So first, let's start with our vocab. So what exactly is a median? Okay, median is in a triangle, a segment from a vertex. Also think of a vertex as kind of like an endpoint to the midpoint of the opposite side. Okay, so let's say you have a triangle. And we're looking at like vertex here, A. This is a vertex, kind of like an endpoint of your triangle. And then we have midpoint over here, B. We know it's the midpoint because it's in the middle. Your median would be this segment right here. Okay, that is considered a median. Now, a centroid is the point of, hello little spider. Little spider friend? Oh, you can't see him. Where'd he go? Oh, there he is on the paper. Go, spider, go. Okay, sorry. The point of concurrency of 3 medians. Okay, so let's say we have our triangle again. Triangle ABC. All right, and we have 3 medians. We have this median here. We have this median here. And we have this median here. Where they all intersect, this right here, is your centroid. It's very important to be able to identify a centroid because a centroid and your endpoint / vertex are the most important parts, okay? Along with your midpoint. All right. Next, we have an altitude. This is also in a triangle. The segment from a vertex to the opposite side or side containing opposite side. In a perpendicular, that's a symbol for perpendicular, which means it creates a right angle fashion. All right, so I'm going to give you 2 examples of what this could look like. What it looks like inside the triangle and what it looks like on the side containing the opposite side. So we have a classic triangle right here. All right, and altitude goes from the vertex straight to the opposite side at a right angle. Now, whenever it says, or the side containing the opposite side, because sometimes we have things called obtuse triangles. Right? If we were to start at this vertex and go straight down to the opposite side, you're never actually going to touch the opposite side. So they say the side containing it. So like, let's pretend like we could draw a make-believe extending side, boom. This and this are your altitudes. All right, and now for an orthocenter. This is the point of concurrency for 3 altitudes. Literally, the only things you need to know about altitudes and orthocenters is their definitions. We're not going to do anything else with them besides understand exactly what they are or what they look like. Our main concern is medians. So goal 2, all right, concurrency of medians of a triangle. Now, normally it's just the theorem states this fraction formula, blah, 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 blah. But I like to break it down to where it's 3 different formulas. You just got to see which one you use. So the important part is to be able to identify the 3 parts of a median. Your first part, the vertex / endpoint. For example, this would be a vertex / endpoint. All right, the next thing you need to be able to identify is the centroid. Remember, this is going to be in the center. All right, so this would be our centroid, that point in the center. And the last part you need to be able to identify is your endpoint. Or no, sorry, lies. Midpoint. Okay, this is going to be on the segment. You'll see that. There we go. So, for example, this would be a midpoint. And here's your 3 formulas that you have. All right. Your first one is going to be 3 times vertex to centroid is equal to 2 times the median. Okay? This entire segment, remember, is the median. All right? The next formula you might use is 3 times midpoint to centroid is equal to the median. And the last one you might use is 2 times midpoint to centroid is equal to vertex to centroid. So these are your 3 formulas. And you're like, that is super confusing. Once you get used to identifying your parts and seeing which formula you're working with, it's going to be a lot easier, especially if you keep these 3 written in front of you. So if I were you, I would make sure you have this in front of you while you're doing your homework. And it's a very short assignment. It's only 9 questions, okay? All right, so let's do some practice. So here's what you do. So you identify what you want. So we want TW. This is what we want. So the first thing I noticed is we want the whole thing. That is a median. Okay, it might seem stupid to identify these parts, but trust me, these right here, you have to be organized. You can't just do them in your head, all right? Then we need to identify what we know. T is a vertex. E is a centroid. So we know vertex to centroid. So what we do is we look to see which one of these formulas contains both of these. And that would be our top one. Our first one has vertex to centroid, and it has median. So I'm going to write that down. So I have 3 times vertex to centroid is equal to 2 times the median. Now let's plug in what we know. All right. Do we know our vertex to centroid? Well, yes, we do. It's 8. So 3 times 8 equals 2 times, do we know our median? No, we do not. So I'm going to put an X in there. It's just easier. I think the question mark kind of confused some of y'all on the last one I did. All right, so we do 3 times 8, and we get 24 equals 2x. And then how do we solve for x? divide by 2, and we find out that our answer is 12. Remember, just to, well, yeah, I made it multiple choice, so you don't have to do that, but the answer is 12. So TW, our median, is 12. So, review. Identify what you want, identify what you know, and see what formula you need to use. All right, let's do some more examples. If we run out of time, you can find these examples in the PDF, okay? All right, so let's look at this one here. They want us to find GL. Uh-oh. We've never done something like this before. That's like the side, right? And we know that GN is 3.3. Well, this is weird. This isn't a median. It's got 2 vertex and a midpoint. Keyword there. Midpoint. Midpoint means it's in the middle, which means these are the same. So we know that our answer is 3.3. Okay? All right, let's look at the next one. We want to know MV. So M is our centroid, and V is our midpoint. So we have midpoint to centroid. And we know JV. JV is the entire thing. That's our median. All right, so let's see which one of these formulas we're going to use. So we know M to C, and we know median. So we're going to use the second one. So we have 3 times M to C equals median. So let's put in what we know. Do we know our M to C? Nope, we do not. So I'm going to put an X. And do we know our median? Yes, we do. It's 33. And then how do we solve for X? Well, divide by 3. Our answer is 11. And your last example, I got like 3 minutes to do it. All right, so we want to know JP. So J is a vertex, P is a centroid. So we want to know vertex to centroid. We know PX. X is a midpoint. So we know midpoint to centroid. So we need to see which one of our formulas deals with both of these. That will be our third formula. So we have 2 times M to C equals V to C. All right, let's plug in what we do and do not know. So we have 2 times M to C, which is 0.5, equals V to C, which is what we don't know. So we just take 2 times 0.5, and we get our answer is 1. All right. Don't forget to do your assignment, and don't forget to take a picture of your notes and turn it in. Bye!